we will today continue from our previous discussion on RDBMS. Last time we saw how to install a SQL Server and Postgres SQL Server. We saw how to install SQL Server and Postgres SQL on Docker, and we tried to connect to these two installed servers from Azure Data Studio. So we will try to explore one particular concept related to database management system today. It's called database normalization. We have seen what it is in the past, what it does to data, but today we will see how it does it. So before we get to database normalization, we will understand first what a database schema is. So there's if you go finding the definition of database schema, you'll find a lot of different things, but it's pretty straightforward and simple thing to understand. So whenever we want to create a database for any client or any usage, a database schema is the first thing that you will have to prepare. So just like whenever you want to construct a building, you want to have a blueprint, you want to have a plan of what you have to construct, how you want to construct, etc., right? Which rooms should be connected, where you should put a door, where you should put it, and so on. And schema is almost something similar, to that, for a database. Whenever you want to create a database, you want to know beforehand what all tables you should construct and how each of these tables should be connected with each other, what should be the parameters based on which each of these tables should be connected. And that is basically, once you create that schematic, that's what you call a database schema. And typically these database schema, they are represented visually, as you can see in the bottom right of the screen. It's a sample of a simple database. So there's one table at the very center, and there are different tables that are linked to this table based on certain fields. And there are different types of schema when it comes to database context. So specifically, there is one type which is called physical schema, which actually means that you're storing data and you are basically physically placing the data, a part of your data in some place and part of your data in some other place for some reason, either for security reason or for backup reasons, or whatever it is. You store the data, some in one place and some in another place. That planning is called physical schema. And logical schema is something which I've just explained, which is basically to create the data structures, tables, and columns inside them, and how each of these data structure tables are linked with each other. So that is what is called logical schema. Generally, by default, when we typically mean a logical schema whenever we are talking about. And so one important thing about schema of a database is that we may have a same set of tables, table A, B, C, but these same tables can be related in a different ways. So it's not necessary that table A, B, and C can only be related in one single way. So, and that is where exactly schemas come into play. So for some sort of SQL queries, you may want these three tables to be in link based on certain configuration. And for some other queries, you may want these three tables to be linked in another based on another parameters. So that is where same tables can be connected, can be present in different schemas, but it is all for a reason, because they are meant for different purposes in different schemas. They are allowing different queries to be looked at different point of views. So we will get into detail at the right time, but yeah, so this is as far as the database schema. And when you're talking in context of data warehouse, we will not get into that at the moment. Data warehouse, there is also a schema there, which is almost on a same definition. It's also basically defining, hey, what data tables do I have in my data warehouse and how they are related. There the types of data warehouse schema is slightly.
Welcome back to Skinny Vlogs. Collaborate வந்து பாத்தீங்கன்னா நம்ம கம்ப்ளீட் பண்ணியாச்சு. வீடியோ வந்து நம்ம சேனல்ல வந்து அப்லோட் பண்ணிருக்கேன். previous வீடியோ வந்து போய் செக் பண்ணி பாருங்க. இப்போ இன்னைக்கு நம்ம சேனல்ல என்ன வீடியோ பார்க்க போறோம் அப்படினா
I am hearing some audio. Okay. So that is basically brief about database schema. Now let's actually jump into database normalization concept. So let me share. So yeah. So I found this one interesting article which summarizes all the important points that are required for normalizations. So we will make use of this article and go through this. So as I said, the first step for creating any database is creation of schema. First we will create the schema for the relational database, and then based on that schema we will actually go ahead and create the database. So data schema is a plan, and that schema, in order for us to develop that schema, there are certain rules and regulations that we need to follow. And why these rules and regulations we need to follow? This is to keep in mind all the some of the factors that we have seen earlier, that data should not be duplicated, the data integrity should always be maintained no matter how many tables I create, and how as I design from the database from schema, actually I create after schema is done, actually I create database. All of those phases should always maintain the data integrity, and all of these things should be there. So that is where whenever we create a schema for the database, there is a certain rule called normalization that we need to take into and apply on the designing the schema. And normalization, I have already given you an introduction to this of what it does. Let's quickly recap of what it does. So basically this data normalization technique is used in order to reduce the data inconsistencies and remove the errors that are possible. So it's basically a way to store the data in such a way that no data errors and data inconsistencies will arise as we keep using the database. So one quick example for that is, so let's say this table here, this is let's assume it's a sample data table, and we have each course and the corresponding venue for that particular course, and the professor and the professor's contact number who is taking up that course. Now let's say some of the simple issues that we have seen to store data like this earlier were, if at all I have to change, let's say Professor George, I see that he is taking 2 courses. If at all this Professor George changes his phone number, then I have to come and change the phone number in 2 places if I had stored the data in such a format, right? So but that may not be the ideal. So a person may not remember to change the phone number at all the place. And again, this is also a simple table, only 2 rows, but if there are multiple rows, innumerable rows, whoever updates the database should update all the places. So that's something we sometimes it may miss out, and data inconsistencies could arise. And other reason is that I know that this Professor George is same person, and this phone number is duplicating, right? Again, so this is another issue why what we saw, the data will always be duplicated and it will not be stored efficiently. So, and there are few other issues that we have also saw, but these are just to recap, these are the 2 important issues: data duplication and data inconsistencies. These 2 are the types of issues we try to tackle using normalization. And what is normalization suggest? Instead of storing it in a single table, split the same data into 2 tables like this, and link these 2 tables based on the one particular linking column, here the instructor's ID. So we can just see that there's a separate table for instructor, separate table for course, and these two are linked based on the instructor ID. And now we can see that there is no data duplication. No matter how many courses that the Professor George takes, we will see this, we will just see the instructor ID duplicating, but his own details will not duplicate. That saves a lot of that's more efficient way of storing the data. And also, if at all you have to update any details of Professor George, you can just come and update in one place, and thereby there is no chance for data inconsistencies also. So this is what data normalization accomplishes. Now let's see how do we achieve this normalization based on the rules. So there are different types of, but to be honest, there are different levels of database normalizations one can achieve. So it's like a step-by-step normalization. So there is a first level of normalization is called first normal, in short form it's called 1NF normalization. And the requirement for the database table or database to hold as first normal first normal form is that each cell in the table should contain exactly one value. So that's a simple rule that we all understand. So for example, if we see here in this table, Professor George is taking 2 courses, but it has given 2 course values right next to Professor George's course code, right? But it is not something that typical relational database RDBMS system recognizes this type of, right? So we only need one value in one cell. So the first normal form condition says that, hey, you need to first ensure there is only one value in one cell and make sure there are unique distinct rows for accordingly. So once we apply that first normal, the table will transform itself into this form like this. So this is the simple step. Sorry. And then we have a second normal form, which is a second level of normalization. And here the condition is that whatever the table, it has to be already existing in the first normal. That is your first condition. Just give me a second. Yeah, so it has to be already in the first normal form. So the table above, which we have just converted to the first normal, it's already satisfying that. And the second condition for a table to be in second normal normalization form is that the primary key of the table should compose exactly one column. So so basically, what I'll put it in simple terms, what it basically means is that, hey, there, make sure that the table that you has at least one column which can basically uniquely identify each of your rows. So that is the requirement for a table to be in second normal form. It should meet the requirement for the first normal, and then it should also have a primary key to be able to uniquely identify each row. So that is the, if these two criteria are met, then you can say that your table is second normal normalized form. In this table, you can see that course code 101.152.154, this column alone is enough for us to be able to uniquely identify this each row in this table. So I can take this as primary key, and that will make itself meet the and also each cell has only unique value, one value, no multiple values are there. So this table itself, we can say that it's already in 2NF form. Now let's take an example of enrollments data, okay, for course enrollments data, and we will see something like this on the screen. So we have a student name and the course for which that particular student has enrolled to, and we can see that each student can enroll for multiple courses, right? Rahul has enrolled for 152 and 154. So Rahul, the student name itself cannot be a primary key. And course code itself, we can also see that there could be multiple student enrollments on the same course, like CS 101. It has 2 students enrolled, so I cannot also have course code itself as a primary key. So that means here we need to do some, this table is still not in, it's following the first normal condition, but it's not following the second normal requirements. So I need to do some transformation to this table so that it is transformed to it meets the second normal criteria. So that is basically how we design tables, how we store what needs to be, what tables I should create, and what each of those tables should hold, in what columns each of those tables should hold. And one way to transform this table to meet for second normal criteria is that split that table into two tables, and the first table will have the students information, individual students, and the enrollment number, and for each of those enrollment number we will have the courses associated with that in the second table. So here now we can see that in the first table we can clearly identify that enrollment number is unique for each row, right? It's for each unique student, so we can say it's already you can take it as primary key, and the same enrollment number is used as foreign key in the second table. So that means, so this particular splitting of this table into these two tables, and making them, connecting them using primary key and foreign key as enrollment number is as made that particular data to meet the second normal criteria. So that is how we transform all the data to meet each of these normalization forms. So basically, again, to quickly summarize, first normal, each cell should have a unique value, single value. Second normal criteria, it should pass the first normal, and say additional criteria, which is table should have at least one primary key. Now moving on to third normal, which is a bit more a level up to already existing second normal. Here, first, before going into third normal itself, we'll try to understand a concept called functionally dependent. This is something which we all understand. It's just that it's a simple to understand. It's basically telling that column A is said to be functionally dependent on column B. It's if changing a value of A, if it may require changing the value of B. So take this example again, the professors and the course allocation table. Here we say that Professor George is from CS department, Professor John is from electronics department. Now if I say I will change this particular Ma 214 course is not taken by Professor George but some other professor, then this department, since it's referring to professor's department, this particular value will also change, right? If I change the name of the professor who is also allocated to that particular course. So that is what it means. So basic functional dependent column means if you change a particular value in a particular column, if other columns value also needs to be changed based on that change you made, then those two columns are said to be functionally dependent. And that's the concept called functionally dependent. And our third normal criteria is actually dependent on this concept. We will see what it is. So here are the criteria for third normal. So what it means is for a table to be in third normal, obviously it has to be first in the second normal criteria, all the rules up until second normal, and then the third additional criteria is that there should not be any functional dependencies. Just like how we have seen so far, the dependency of instructor's name and department, there shouldn't be any such dependencies. Only then your table will be called third normal normalized form. And how do we achieve that is let's actually again, so take the same table here on the top. We have professor's name, professor's department, and course venue and course code. And by splitting this table again into two tables where we have course details and instructor details as separate tables, we can say that just hold on. Right. So basically, just checking one last thing. Yeah, okay, understood. Yeah, this is the point here I'm looking for. So what it means is, again, this particular rule, the functional dependency, why there should not be any functional dependency is explained here. Basically, when we have this, again keep in mind the main core point behind all this criteria is to reduce inconsistencies, reduce duplications whenever we maintain, update, insert, delete data. So here we have it simple table, and if we want to change the professor name, we have to make sure that all the functional dependent columns should also be changed accordingly. But that again, we know that how it can lead to data inconsistencies when people forget to what are the functional dependent columns and update each of don't update each one of them. So that is the reason why third normal form suggests that, hey, if you create a table, make sure that there are no functional dependencies at all. So thereby, this particular table will split up into these two tables at the bottom, and here we are having Martu courses as separate details and instructors as separate details. If at all you have to change a particular course allocation to a professor, you just come to course table and change the instructor's ID accordingly, and it will automatically update all the functional dependency columns, department or any other contact numbers in a one single update, without having to manually take care of each and every functional dependency column manually. So when a particular table meets these three requirements, then we can say that it's a third normal normalization form. So far the conditions are single value in a single cell, there has to be a primary key in a table, and third one is that there shouldn't be any functional dependencies inside the table. And if we can make sure that these three are met, your data table or database is considered to be third normal form normalized. And that third normal form is pretty much practically the place we can arrive at in terms of normalization on database. So all this, any further level from third normal is mostly considered to be theoretical, and it's can only be applied on very complex databases, which may not be, which will be very rare to come across. Third normal is mostly will be considered sufficient in most of the cases, but if at all we need, we can proceed further as well. So we'll look at one more and we'll close. So there is something called Boyce code normal form, which is just a slight extension of the third normal criteria on functional dependencies. And what this says is that, I will actually keep it simple. BCNF normal, what it says is that third normal says there shouldn't be any functional dependency, but BCNF says that, okay, if at all there is a functional dependency, it make sure that that functional dependency meets either of these criteria. If that functional dependency meets either of these criteria, then the data inconsistencies and data duplication is minimized. So, and what are those two criteria? Is that if you are saying that column A is dependent on column B, then make sure, if column B is dependent on column A, then make sure that your A is a super key. Super key is the basically like a primary key only. So you can make sure that your dependent column is dependent on your primary key. If that is the case, then okay, then no worries at all. Or else make sure that your functional dependency between columns, whatever if you have noticed, it's not a very important functional dependence. So it's a trivial dependence. So what it means is, let's actually quickly take an example. So take this table again. Super key is basically a set of columns that help you identify your rows uniquely. So you can also take that as a primary key, and these are the few combinations based on which you can consider super key for the above table. You can either take course code itself and that can act like a super key, or you can take combination of course code and professor's name that will also help you identify each row uniquely. And there's a third combination, professor's course code and professor's mobile number. Now there's a definition called candidate key, which we'll not get into at the moment. And what the trivial functional dependency, let's just try to focus on that. So trivial functional dependency means that, hey, course code and if I have course code and professor's name as my super key, then I'm pretty sure that if I change my course code here, my professor name will also change because my allocation is already fixed. So that's what a trivial functional dependency means. So that here basically they're explaining the same thing. Course code and professor's name. Course code is obviously dependent on the professor's name, and that sort of trivial dependency is allowed. That's what BCNF means. If either of these two criteria is not satisfied when there is a functional dependency, then it cannot be converted to BCNF. So if you want to get to higher normal form BCNF, you have to make sure that the functional dependencies are falling into either of these two criteria. And there is a fourth normal and fifth normal, which is pretty theoretical at this point in time, and there is also a sixth normal which is currently in development. People are studying on that, trying to develop it. But mostly for our practical cases, third normal would be most sufficient. We don't have to worry at the max, BCNF at the max, but not beyond that. Nothing is required. But if at all you're curious, I would recommend you explore further on fourth normal and fifth normal. I think I'll stop it here. If you have any quick questions, I'd be happy to answer them.
And Jagdish, can you scroll to second normal form?
Yes.
So
yeah, the definition. Yeah.
So like a bit down.
Okay.
So after normalization, we are replacing the enrollment number with code, right? What if like one student take two courses, then again the student name column we will have his name twice, right? So
no, it will not. So Rahul here is taking two courses, right? Rahul CS 152, 154, and here we have given Rahul one enrollment ID, and for that one enrollment ID we have given these two IDs, courses. Okay. Any other questions?
Is there any commercial software of sorts that will allow us to do this particular split in different table, or should we do it manually? This column should be in this table, those columns should be another table.
Good question. So normally this all this normalization and all will happen, as I said, in the schema designing phase, and there are lots of tools that are actually they will help you with all this database schema designing and all, which will take into account the normalization, and that's definitely help if you're looking for some sort of a tools. For simple tables, we can do it manually, but when you're talking about large databases, you're dealing with almost 300, 400, or if not more tables, and there you definitely need some sort of a tools to help you with all the designing and all.
Okay. Thank you.
Okay.